The treadmill lights flicker, then a sudden hiss slices through the gym, an invisible pulse that seems to echo from the stars themselves. Nobody can see it, but every breath you take carries atoms forged in supernovae, now dancing inside your muscles. How could this cosmic fireworks explain why we feel light or heavy when we run? The answer waits just beyond the next step. In a quiet corner of the universe, a star once burned bright and then exploded, scattering its inner material into space. That explosion forged heavier elements: carbon, oxygen, iron, atoms that later became part of planets, oceans, and living cells. When you lift your hand or take a deep breath, you are holding these same atoms inside you. The idea that every atom in us comes from stars is not poetic. It follows directly from the physics of nuclear fusion in massive stars. In those cores, hydrogen nuclei fuse into helium, then heavier elements up to iron, until the star can no longer generate energy and collapses into a supernova. The shockwave spreads these atoms outward, where they become dust grains that eventually condense into new stars, planets, and life. The link between our bodies and distant stellar explosions is now being explored in two very different ways. On one hand, NASA's astrophysics program pushes the limits of space observation with missions like the James Webb Space Telescope, which captures infrared light from galaxies billions of light years away, revealing how stars form and die. On the other hand, medical physicists use advanced imaging techniques such as magnetic resonance imaging (MRI) and positron emission tomography (PET) to peer inside living tissue, mapping structures invisible to the naked eye. Both fields rely on instruments that detect signals far beyond what our eyes can see: light waves, radio waves, or particles. By comparing footage of distant supernova remnants with high-resolution scans of muscle fibers and neuronal pathways, scientists can begin to trace a common thread: atoms moving from one extreme of the universe to the other. In June 2025, a short TED Talk captured this idea in a single minute. The speaker explained that each atom in our bodies originated from stellar nucleosynthesis, the process by which stars forge new elements. They highlighted how exercise shifts the distribution and movement of these atoms within muscles. When we run or lift weights, blood flow surges, oxygen is delivered to cells, and metabolic pathways ignite. These processes involve the exchange of carbon, nitrogen, and other elements between our bloodstream and muscle tissue. The talk suggested that by monitoring how these atoms shift during physical activity, we could trace a direct link back to their stellar birthplaces. To understand how exercise can act as a portal to cosmic history, imagine a single carbon atom in your lung tissue. That atom once resided in the core of a star, fused with hydrogen to become part of a heavier element, then was expelled during a supernova. It drifted through interstellar space, became incorporated into a dust cloud, and eventually landed on Earth as part of soil or water that nourished early life. Over billions of years, it entered your DNA, then your bloodstream, and finally settled in a muscle cell. When you sprint, blood flow spikes. Oxygen molecules bring more of these atoms to the muscle fibers. The movement of atoms during exercise mirrors the motion of gas and dust around stars, only on a much smaller scale. Modern imaging can now capture this movement in real time. Functional MRI tracks water protons as they move through brain tissue, revealing how neural activity changes during a workout. PET scan use radioactive tracers that mimic natural molecules. When you run, these tracers spotlight metabolic hotspots where atoms are being used more intensively. By overlaying the data from space telescopes with the data from human scanners, researchers can visualize a continuous journey from the bright flash of a distant supernova to the subtle glow of a heart beating under exercise. The implications go beyond scientific curiosity. Recognizing that our bodies are made of stardust can shift how we view health and fitness. If each breath you take brings you closer to your cosmic origins, then exercising is not only about building muscle or burning calories. It's also about reconnecting with the universe's grand cycle. When you feel a surge of energy during a run, think of that as a reminder that you are part of an ongoing story that began billions of years ago. NASA's astrophysics team has already begun to share these stories through public outreach. Their website lists current missions such as James Webb and Lucy, which study cometary bodies and distant galaxies. They produce videos that show the birth and death of stars in vivid color, making complex physics accessible. At the same time, medical researchers publish findings about how atomic-level processes influence muscle growth, heart health, and brain function. By juxtaposing footage from both domains, documentaries can create a powerful narrative, the unseen link between our movement and the cosmos. The journey of atoms is not merely theoretical, it has practical consequences for training and recovery. Athletes who monitor biomarkers like lactate or oxygen saturation are essentially tracking how atoms move within their bodies during stress. Coaches use this data to optimize performance, ensuring that the right elements reach the right tissues at the right time. If we think of these elements as remnants from stars, it becomes easier to understand why proper nutrition and rest are essential. They help replenish the building blocks forged in distant suns. In a final moment of revelation, we see how the invisible journey of atoms, from supernovae to our cells, directly affects how we move and feel. The heavy feeling you experience when you lift a weight is partly due to the increased demand on oxygen carrying blood vessels. Those vessels carry iron-rich hemoglobin molecules that were once part of a star's core, finding oxygen so your muscles can work. When you sprint, the rapid influx of carbon dioxide signals your brain to increase heart rate and breathing. This gas exchange involves atoms that traveled across the galaxy before finding their way into your lungs. Each breath is a reminder of the cosmic cycle, each heartbeat an echo of stellar collapse. Bringing together space exploration and human biology reveals more than just scientific facts. It shows how interconnected we are with the universe. The same instruments that capture light from distant galaxies also map the internal landscapes of our bodies. Both fields uncover hidden structures, nebulae swirling in interstellar dust, or neuronal networks firing beneath the skin. By acknowledging this link, we can appreciate exercise not only as a means to stay fit, but as a way to connect with the stars. Now that you understand how atoms travel from supernovae to your muscles, what does that mean for your next workout? Will you run faster, knowing you're literally moving stardust? Will you choose to feel lighter or heavier when you push yourself? A. Feel lighter, remembering the weight of a star's collapse. B. Feel heavier, honoring the gravity of the universe. If you enjoyed this exploration of our cosmic roots, please subscribe and let us know what part of the universe inspires you most. We'll see you in the next one.